Welcome to another walkthrough of Audio Basics. I am Ryan Black here in REB Record Studio, and we are going to take a look at signal flow and gain structure basics. These two concepts are central to all audio systems. Signal flow is the order of devices that make up the path an audio signal takes. This can be analog or digital. And whether you work in live sound or theater or corporate sound or installed systems or DAW composition with MIDI synthesizers or game audio or car audio or any other field, this is central to understanding the somewhat complex systems that allow audio to be integrated into our lives. Gain structure is understanding the components within that system, the components that make up that signal flow, and ensuring that the signal at its input and output are at full quality. What I mean by that is within any part of the system, you cannot go into distortion, and you also cannot go so low that the noise floor of the system becomes obvious. And understanding each component will allow you to create high quality audio. That is key to working in the field as a professional. I'm going to take an overview here. These are basic ideas, and we are going to see examples of where you might run into this quite quickly. The first example here on my right is a console. And this is the manual for the Mackie 1604 VLZ. This is a console that's been around for a while. It's relatively small in stature, but it packs a lot into that compact package. And I've used this in many live sound, smaller gigs and stuff with analog equipment. Solid console. In any console, understanding signal flow is key, and often consoles have very similar structures of how that signal flows through individual channels. As you can see here, this is channel 1, and then from each of these individual channels to a master section where there is more complex routing available. And the arguably simple part of signal flow is understanding the individual channels. Understanding that an input to the top of the channel here moves through the channel, through these processors, and then goes to an output. Once you're in the output section, though, there are many options. And this is true of most consoles and also of digital systems in a DAW, in a recording environment. Some of the places on this particular console that you might go with the signal include groups 1 and 2, groups 3 and 4, or left and right main outs. That might sound a little like, okay, great. But it gets fascinating when you consider that essentially these are all the same. You could route 6 different paths for each channel on this console, just on the master output. And the pan control would allow you to go to just output 1, for example, or just output 2. And you could also go to just output 3 and just output 4. So you could have one channel go to output 1 and 3 and main left out. if you pushed all of these buttons in and panned it all the way to the hard left position. Understanding how a console works is essentially understanding signal flow. I'm not going to go into the details of why you might do that, but I will jump up here to explain one other key concept of signal flow that is central to almost every audio system you'll work on, and that is auxiliary sends. So in addition to the 6 outputs in the main system, there on this console are 4 auxiliary sends. Actually, there's 6, but you can only access 4 at a time. And that's usually to save money or to save space on a physical console, an analog console. So here you have 1 and 2. These can be pre-fader or post-fader. And then you have 3 and 4. And you also have 5 and 6. Sorry about that. 5 and 6 here on the right side. And you can shift between 3 and 4 or 5 and 6. You cannot do both on this particular console. And those are individual outputs. So what you might do is, if let's say this channel is the vocals, you might have the headphones for the vocalist on an aux channel 1. So this audio for the vocals would be sent, that the vocalist wants to hear, would be sent on aux 1. If the vocalist wants less guitar, say that's on this next channel, I would turn down the guitar level and up the vocal level to make sure that they can hear themselves clearly. The guitar player, on the other hand, might go, I don't really care if I can hear the vocalist. I need to hear lots of guitar and kick drum. So I'd give them a lot of kick drum, a lot of guitar, and very little vocals. These mixes do not affect the master mix that might be going to a tape recorder or a multi-track tape machine. They're only for those individuals' headphones, and often these mixes are not great sounding mixes, like from a listener standpoint, when working in live sound or in a recording studio situation. They're what the players need. If we go down the channel strip, or actually let's go up the channel strip to start, at the top here you will see a gain and trim control. And this is the first place where I'm going to focus on gain structure as a key element of a console, or of understanding audio. This is the input gain for either a microphone or a line input. If you plug into this console, scrolling up a little bit, you can see the back of the console here, I believe. If you plug into this console on the XLR input, you have directly gone into the preamp of the console. And if you have connected into the line input, you have directly bypassed the preamp and are now in the trim level control. Those are on the same knob. Once again, save some money, save some space on a console, but very, very common approach. So we can adjust, and we need to make sure that that gain is as high as it can go without distorting. That's key, without distorting. Because if you introduce distortion here at the very first point of gain structure, you cannot get rid of it. It's in the signal. The signal in of itself has become distorted. Now, if you want to do some cool distortion thing for an effect, great. Do that because you know how to use gain structure and you want to do that. And I'm going to show an example in a second of a console that literally is designed to allow you to distort on your preamps. And I've done it and it sounds great. But you have to be very intentional about that. You don't want to distort everything. You don't want just every single drum and tom to sound like big and distorted. It just sounds like you don't know what you're doing, because if that's the case, that's usually what's going on. This gain controls and gets the microphone level, if we've used the XLR input, up to line level, which is an appropriate voltage for the rest of the equipment, all the way through our analog to digital converter into our DAW for recording, or all the way through our signal path. As we move down the path, we then get to an equalizer, which allows us to modify frequency. Same thing here. If we're going to boost massively in our EQ, that has the potential to distort because we're actually adding more gain at a specific area. So we have to be careful not to distort at any one of these specific issues. But also, if we take all of these knobs on an EQ and turn them down, well, we've just lowered the entire signal essentially by like 12 to 15 decibels. So now it's too low. And how do we get it back up? Well, we've got to, I guess, crank our fader up really high. Well, now what if that signal needs to get louder? Well, we have no way to do it, right? Because we messed up our gain structure. So that's a basic idea of gain structure on this specific console and how you might approach those two concepts of gain structure and signal flow. Now I'm going to jump over to this channel strip, also from a console, but this is a recording console that is far more versatile, let's say. It's also, I don't know, 400 times more expensive. Each channel on this console costs the same as 3 of those entire consoles. And this is a Duality, SSL Duality console, and this is the channel strip. And on this channel strip, I'll zoom in a little bit so you can see it here. The input has a preamp gain, this red knob, and also a second trim control. I know it's called drive. I'm not going to go into what's going on there, but you actually, oh, sorry. It has an input, my bad. It has an input preamp gain, this red knob, and a trim control here, the black knob. The black knob is a trim control that comes after the preamp. Same concept. If you plug into the line input, it bypasses the preamp. But if you plug into the XLR input for the microphone, it goes to the preamp and it also goes to the trim control, which means you could overload the preamp and then adjust it back down with the trim control. Very useful to have both of these controls here, but it adds a significant amount of space to the console and is not always useful. 90% of the time, 99% of the time, you won't use it. But the SSL has done an amazing job of creating some of the digital versatility into an analog channel strip for this console. Below that, once again, gain structure becomes just so important. We have built-in analog compressors and gates that we want to maintain our signal flow through. And below that, we have a fully parametric analog EQ, which is not that common in analog consoles. The 2 middle bands also have bandwidth, as well as obviously gain and a specific frequency. So you can pick a frequency, for example, here would be 2000 hertz, and you could increase that by what sounds appropriate. You'll notice there's no specifics here. I think this goes up by 15 decibels though. And then you can also adjust the bandwidth. Very common in digital systems, not very common in analog systems. And then you also have some high-end EQ, shelving EQs or bell curves. And understanding that signal flow and gain structure will allow you to manipulate these frequencies without distorting or without bringing the level so low that you add noise. And then just like our Mackie, we have some auxiliary sends, though there's a dedicated one for the Q, which is our headphone feeds on this particular console. And then below that, we have panning. And in this case, you might notice there's 4 pan knobs. Well, signal flow, what's going on? Why do I have 4 pan controls? Well, they're not all pan controls. This is actually a 5.1 setup on an analog console. So you have left and right here in the bottom right corner. Then you have left to right focus or left center right focus, which changes how it interacts with the center speaker. And then you have front to rear is what this knob is. And here is your low frequency effects, which is your subwoofer. So on just the main outputs of this channel strip, you have 6 options. In your auxiliary sends, you have 4, or effect sends, you have 4 options, so that's 10. You have 2 different Q feeds, each are stereo. So you have stereo A and you have QB, so that's 14. And there's also an insert point, that's 15, and there's side chains and so forth. So at a minimum, there's 15 different locations you could easily send this signal at any given time. And you might say, why would you need that? And then when you get to a point where you're in a studio working with it, you're like, oh my gosh, I don't have enough. It's fascinating and complex and fun. So I just wanted to show you sort of a next level up. All right, so how does this sort of manifest itself in why is it important? That's some of the details, and I'm going to finish up with just showing you a couple more examples of signal flow at a more macro level. So if we go all the way out from that Mackie console, this is actually a slightly different console, but similar. This is a signal flow diagram for how you might plug in all of the external equipment you might use. How would you plug in your digital delays and reverb processors? And how do you get your main outputs to an amplifier to your speakers, right? How does all of this work? What about if you want to do a mix down while you do a multi-track live output for a PA system? All of that is possible. And it's possible and duplicated in DAW setups. Understanding analog equipment will allow you to work faster. It will allow you to work cleaner. It will allow you to understand multiple different DAWs and how they work. The opposite is not always the case. So I highly recommend trying to get your hands on analog gear, even if it's just to play around and make it work or distort it or do something fun with it. Learning that it's unapologetic, right? Analog gear does what you tell it to. And if it doesn't, it doesn't. Like if you don't know what you're doing, the gear doesn't care. It doesn't try to help. It just exists. And I think that's in digital systems, there's often sort of helpers going on, right? You'll add this and it adds a bunch of other stuff. You add this and it adds a template for reverb and it sounds okay. And you're like, oh, that's how you do reverb. That's not how you do reverb. And if that's the approach, you end up with, mixes that sound like you didn't take the time to do it and be careful and be an artist and be a technician and understand the tools. So I highly recommend that. Now, if we take it down to the smaller level, so that was a super level, a high level. Now we're going down to a sub level. We're looking at the actual diagram of a channel. And this schematic diagram shows us the signal flow from an XLR input or a line input, same thing we saw on the console. Here going up to get phantom power if we decide to turn that on, going to a preamp with a gain control, and then going through an EQ section here. This is a parametric EQ. And there's also an insert, which I mentioned on the SSL, and you can turn the EQ on and off, et cetera, et cetera. So this is how your ability to read this would allow you to look at this, understand how this console works. In this case, it's a Midas channel strip, and then bring that out to a more to the console before you were even on site using it. And I'm a fan of reading manuals. I think that's one of the best things you can do. Here is that same diagram for the SSL, and you will notice there is a lot more going on. So I'm not going to go into the detail on how all of this works, because as I mentioned, SSL has put in a bunch of places where you can actually reroute things as you might do in a digital system, but they're doing it with analog equipment. But it's a complex and fun diagram to figure out and learn, and then be able to execute in a studio, or even better, in front of clients, and they're like, whoa, that's amazing. Oh, I'm going to switch over here real quick. Sorry. This is also signal flow, and this is the input list for my studio. And each of these represents an input snake that is somewhere in the studio. Main snake, acoustic drum snake. There's actually 3 snakes over there. There's a digital drum snake. There's a guitar, and Chandra is a computer system that I have set up for visual effects. And then there's an ISO booth. And here is all of the different potential inputs, right? Some are normaled, which means directly connected to a preamp and some are not, like this sub kick. So I would have to physically patch that in. So all of the snakes come into a patch bay, the microphones go into the snakes, and then I can patch them wherever I want to get into my DAW. And going through, and here's those physical inputs on the different audio interfaces that are in there. All of these inputs are available, and there's a lot of them, right? And this is a small studio. This is just my studio. There's 53 different inputs I have set up. I don't have 53 preamps. They're not all plugged in. If I want that specific trumpet mic, I have to physically patch that. It's on a patch bay, and I have to physically patch it into a preamp to get it to deal with the gain structure. Just to continue on, just to show you a little bit, I also have done this for the outputs in the studios to feed headphones here. And then I, in fact, have also done this for all the computer monitors that are in the studio. And this is just a diagram of all, I know it's too much to take in just looking at it quickly here, but of all of the different places the signal goes in a studio. And once again, a small studio. Here's a simple input list from from live streaming that I've been doing recently. And same sort of thing. I can see what the position is, who it is, what the instrument is, what their actual physical output is, what it looks like, where it's going, if it's going to a loop pedal or not. I have a mixer pre a loop pedal, so I can do a mix into a loop pedal with different instruments. And then where it ends up on an XR18, which is a Behringer portable mixer, so forth. So trying to keep track of all this stuff is vital to being able to pull off a show. And that is why signal flow matters. And signal flow is awesome. And the signal flow and gain structure basics are something that I would encourage you to continue to learn, to continue to dive into, and to get your hands on the manuals for equipment that you use every day. Thank you. It's a little longer than I expected, but I hope you learned something about signal flow and gain structure. Catch you next time.